Okay, so I skipped the first part of recording this, but we're doing the review and somebody asked about problem 4 on recursion. Okay, so we want to move from where we're at up to a one item element, okay, or one item list. Okay, so if we look at that at every step, if we look at A sub 0, okay, and then the rest of A is going to be A starting at 1 going to the end. Okay, if we divide it into these two pieces, okay, so if we look at the large of that versus the large of that, okay, then basically that's our recursive step. Okay, so in this case, the first time we're going to say which is bigger, 1 or the largest of the rest. Okay, so we're going to call that again, we'll call it on the 2, 3, 4, 5. Okay, and then we'll compare 2 to the 3, 4, 5, which we'll call again, compare 3 to the 4, 5, which we'll call again, and compare 4 to the 5. Okay, then it calls again just with the 5. Okay, so then 5 will be the base case, and it's going to start coming back down from there. Okay, so hopefully that makes sense, but that's the general idea we're going to follow here. Okay, so our base case here is going to be if the length of A is equal to 1. Okay, if we do that, then we can just return, only if I can type, we're going to return A sub 0. That's all there is. Okay, if we send it a list that contains 12, what's the biggest number? 12. It's also the smallest number. Okay, so that's all we have to deal with. Okay, so we know that should be okay. Is that straightforward enough? Are there questions why I've gotten that? Okay, so that's our base case. Okay, so now let's look at what we have left. So now we want to see if we're to the else, it means that our list has more than one element. Okay, so I have to figure out which is the biggest one. Okay, so the question I want to ask here, if A sub 0 is greater than the rest of A, basically, okay, is what I'm questioning, but I have to make a call to large here. Okay, so I'm saying if my current A0 is bigger than the biggest for the whole other list, okay, if that's the case, I'm going to return A0. Okay, else, what am I going to do else? I did this problem the other day. Let me think about this. Okay, so we're going up, and we can go ahead. Let's do a 2 just to help us think about this. It's good that I've forgotten it. It'll be a better example. Let's say I've got 1 and 5. That's all I've got. Okay, so the first time I do it, the length is not equal to 1. So I'm going to be asking the question, is A0, which equals 1, okay, is that greater than the large of 5, which will come back as 5. Actually, I need there to be 3 elements just so I can see what happens on the else. Okay, then the large of that. Okay, that's going to be the first thing that asks. Okay, if this, oh, but that'll be a number. Yeah. Okay, so yeah, this large A1 colon will stop until it resolves a number, but it should have a number by then. Okay, and I remember this now. And instead of having, that's going to call the function twice. I don't need to do that. I can just capture it. I can just say, I don't know, some x is equal to the large of A starting at 1 and going on. Okay, these recursive are slippery programs because you don't have it, and for me it just all fell out at once. Okay, so hopefully you saw that. Okay, I can replace this way. I think it's a little clearer anyway, but it also avoids calling the function twice when you don't need to. Okay. So what I'm saying now is if the length of A that I send to this version of large is equal to 1, there's only one element, then that's the largest, return it. If not, I'm going to determine the largest of the rest of the elements, okay, which is going to hold it until it gets to the end, until it gets to the base case, okay? That's my recursive step. Once I know that, then if my A sub 0, okay, the current first element is the biggest, I return that. If not, I'm going to return the biggest of what's left, okay? And then to run through this again, in this case, if we do it with a 154, okay, at the first time, so this is the large, the first time, okay, is going to have, let me make columns here, I think may make the most sense. Okay, so we're going to have the A sub 0, and we're going to have the large of A 1 colon. Hopefully this makes sense, okay? So the first time through, A sub 0 is equal to 1, and the large of the 5,4 we don't know yet, okay? So we're going to call large again, and let me go ahead and put these in here. This is at 1, 5, 4. Okay, and that's a 1. We don't know that yet. That's still correct. Okay. Okay, so we're going to have to now call this one. Okay, so that's going to be a large on the 5 and the 4. Okay, so for that one, the A0 is a 5. Okay, and we're also going to have to calculate, and these are notes, not code. I assume that's clear. The large of A1 colon. Okay, so that's going to, so again, the call in 24 is stalled, waiting on the answer of the large of 5,4. The version of large at 25 is stalled, not stalled, you know, waiting. It's waiting in memory, okay, until we get to the large of 4 now. Okay, so A0 is 4, but we're in the base case now. It's only have a length of 1. Okay, so we now know that the large of 4 is 4. Okay, so we get a 4 there. Okay, we now know that this one is a 5. Okay, and that's gone away, and that's gone away. So when it gets back to the first one that we've called, we know that 5 is the biggest. Okay, so that's how that's going to work. So let's try this, see if it works. Okay, so it's going to return that value here. So let me do A is equal to, let's do the one I just did, doesn't really matter. 1, 5, 4. Okay, and then I'm going to print the large of A. I haven't dealt with the precondition yet, but I just want to see if this is working. Okay. Doesn't like something. What doesn't it like? What can it not like there? Probably means it doesn't like something up here. That should be okay. Does anybody see anything weird with that to give a syntax error?
Now that I think about it, I think that was the issue that I was running into.
Yeah.
But I just never figured it out. I'm not sure what would be wrong.
Yeah, I got this to work before, so I'm not sure. Oh, I didn't. Here's my problem. I didn't define it. There we go. That makes sense. That was dumb. Yeah, that's what that issue was. And this is going to be back over there. That was really weird, but okay. Let's see if that fixed it. Doesn't like the unindent. Is that not all the way over? It wasn't all the way over. One more time. Okay, we get that. So we got something wrong somewhere. Okay, so let's see what we're doing wrong here. So we can see, let's go ahead and print out some stuff here. So let me go ahead and see what this is doing. Oh, that's part of the problem. My indents are all messed up. I wonder if that's the issue. Probably not that easy, but one never knows. Let's fix it anyway.
Could it be something to do with the last else step? Like, why is it just X?
That's exactly what it is, because X is wrong. Yep, you saw it as I did. I'm like, why does it just say X? Yep, that it didn't return anything. What did it return? It returned to none. So yeah, that's probably it. Let's see if that's all it was. Let's try it now. Yeah, that worked. Okay. It's worth doing, I think, just to see what's happening here. We're just going to print something, doesn't matter. A as we call this, just so we can see the calls happening. Okay. And we can even put a print in here when we hit the base case. Okay. Just to give some idea as to what's happening. Okay. And we see, as my diagram showed, that we first run it at 154 and at 54 and at 4, and we hit the base case when we're at 4. Okay. So if you're having trouble with your recursive algorithm misbehaving, those prints can often let you know what's going on. Okay. We don't really need those though, so we can go ahead and take care of these. Okay. We do have to worry about our precondition though. Are there questions about this yet? You could also put something in, well, in fact, let's do this. We could just say print the recursive step A. Okay. Which again shows we have a recursive step at 154. That's the first time through. The recursive step at 54. Then finally we get to the base case at 4. Okay, so again, on a longer program with more data, this could really show the progression of our program. Okay. Let's get rid of these for now.
Should we add more like higher and lower numbers into A to kind of see how it's working a little more?
Sure.
Okay.
Okay, better. And that was a good example. That shows exactly what's going on. Right? It shows exactly what's happening. Okay. And at one point, when we get to the base case, all of those are in memory. Okay. So we get to the 21's the last thing. Okay. Here it's going to return back to here the 21. Here it's going to turn which one's bigger. Okay. The 21's bigger. It's going to return which one's bigger here. Okay. That's the 21 there. Okay. Now the 45 is biggest, and 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 back here the 45 is biggest. Okay. So it's going to add all these to memory, and then it's going to take them all off one at a time, returning the largest. And it worked. It is 45, which is correct. Okay. I'm glad I recorded this one. This is going to be useful for people, I think. So Jason, other questions?
No, that was all I had.
Okay. And it does the recursive step feels weird sometimes, especially with lists. Like, what exactly are we doing? You know, but I think this helps. I didn't have to. I could have made the call both times, but it's less efficient to make the call twice. Okay, so I'll just set it once here, and then I can return the biggest one. Okay. Other questions on anything? Again, I did put chapter 9, problem 1 on dictionaries out there if you're having questions about dictionaries. Oh, we didn't finish this one, the precondition. Let's finish that. Okay. This one doesn't really have a try block per se. Oh yeah, it does. It has a recursion. All the recursive ones seem to have that. So let's go ahead and put a try in here. because this is where people lose points and don't need to. And we're not, if we were allowing them to enter numbers, we'd have to put a value error. And if you put them all, that's okay too. But the recursion error, we definitely have to have. Okay, and then to say print list too long. Okay, see this one had to say. Yep. Tom predated my remembering that I'd forgotten to put that stuff in. Okay, so yeah, so we're going to do a try on that stuff, and then the except would be the recursion error. That recursion, I guess, one S doesn't it? Yeah, turns purple, you're good. If it doesn't turn purple, you're not. Okay, and again, we only need to try in our main as a general rule, because if the error occurs in the function, it's going to come back to main anyway, so you don't need to catch it a bunch of places. Okay, so that's all I can think of that we would have here for the preconditions on this. Let's see. I'm going to say if not is instance a of list, print must send list. Now we do have one other error. We have the index error. And that's why a couple people in the first exam put all the errors every time. I'm guessing if they were smart, they did it on the first program and cut and pasted on all the others. That's not wrong. So I could put the IO error and the value error and the zero division error, and then you're sure not to forget any of them. Okay, so that's not a bad idea. Type it on the first one, cut and paste to use for the others. Okay, but we do have those errors. Okay, so if we get to that, must send a list, and then we're going to return, I don't know, something. -99, because we know that's going to be wrong. Okay. I guess we could enter a list where -99 is the biggest, but we're going to hope that's not the case. Okay, and there's not really a post condition here. So I wouldn't worry about a post condition on this one. It's not that kind of a function. That should be it. That would be a 100 on the exam for this particular problem. More comments, actually. You'd lose probably a point or two for not having enough comments. Questions on this one?
Why doesn't the recursion error have like as error on the end?
Yeah, I'm not sure what it says. I mean,
Mhm.
maybe it does, but usually it's more specific, like number's too big, list is too long, and I just usually put my own.
Okay.
You could do that, and I wouldn't pick off because I assume it gives something, but it's probably a more generic error. The ERR is kind of a cop out. We really probably ought to be putting better error messages, but on an exam, I'm not going to care. You can use the ERR for all of them, except remember the one it doesn't work on. If there are post conditions and you use the assert, then the only error it gives is assertion error, which doesn't tell us anything. So if you're doing an assert, you have to do your own custom error message, but on anything else, you don't have to.
Okay.
Okay. Other questions?
If no one else has any, then I actually do have a question. It's like really quick. Could you just review like super briefly how like what errors to use when? Because I'm still kind of struggling with that.
Okay, we can do that. So let me. Okay, so you guys may have to help me remember everything we've done so far. So if we have the value error, okay, and this one is when you use an int or a float or some kind of conversion. Okay, so if I were to say something like x is equal to int input, enter a number. Okay, that's when that one would fire. Okay, and then I could go ahead and put a print in here. value error. Okay, so if I run that one, if I haven't messed it up in some other way, if I enter that, see that value error comes back. Okay, that's where that one gets caught at. Okay, we have the zero division error. Which is pretty self-explanatory. That's when you divide by 0. Okay, print. Okay, so I could just have in here. That should force that error. 5. That is going to pop up the zero division error. Okay. If you have a file, which I don't, so I'm not going to be able to trigger that one, but that's the accept IO error. Okay. That's a file error of some sort. So that's either a file not found, or it's the file not readable, or no hard drive, any of those things. Okay. Then the index error we have down here is whenever using a list. Okay. Recursion error is, whenever doing recursion. Okay. We also have a key error. And the key error is when you have a dictionary. I think that's it. Can we think of any others? And again, you can put all those on every problem, and it's not incorrect. I think if it were me on the exam, the very first thing I did, put in a try, type in all these accepts, make a note about preconditions, postconditions, and then cut and paste that into the other two problems. Just, to add structure. Because I know with me, I always go really fast because I'm afraid I'm going to forget stuff. So that would not be a bad idea.
So for the recursion error, the list too long, like I'm kind of confused about how to practically use that one.
Yeah, so what's happening on the recursion error, I think in the other example, or maybe on the chapter 12 video, if you go too far, you run out of memory. Okay, and it's usually like, I forget what we were doing, but it was the factorial. On the factorial program, if your number's too big, you do too many recursions because it has to do one version of each one and it blows up. Well, here we're not going to have that problem, but we are going to have, as you see over here, a different version of it for every one of these. Okay, so if I would do something like A is equal to, I think I can't force this, maybe list range, I don't know, big. Okay, if I do that, I'm probably going to run out of recursion. What didn't it like? Oh, why didn't it like that? And that's where the error is at. Oh, it didn't like there was nothing here. I'm just going to get rid of that because we don't really need that one. That's what the issue was. I didn't finish that one up. So I enter a number, whatever. Oh, that's stopping me before I got there. So let's get rid of that. Oh, it worked. That's really weird because it didn't work. It printed out what it printed before. Oh, it's not there. There we go. Oh, it's still working. it clearly can't work. Let me make sure it's paused somewhere. Let me hit. Okay, let me go ahead and here put in a print. Length of A, I don't print A out. Just so I should be getting something back here. Maybe a bad example to do this, but we'll see what it does. Oh, it's still trying to create this. That's what's taking so long. Yeah, that's not a good example, but the idea is if you open up too many versions of the function, you use up too much memory. That's when the recursion error is going to happen. So in this case, it would happen because the list is too long. Okay. Yeah, it's all just now running that range function, which is taking forever and ever and ever, which is strange. Oh, it just stopped, which is interesting. Yeah, I'm not sure why, what that's doing. It should have done something. I don't know why it's not working. But the example with factorial is a better example. Okay. Anybody else have any questions? Or Amber, if you have more questions, feel free to ask. Okay, so I think that's all of the errors that you could have. Okay. Other questions on anything?
If no one else has questions, then I kind of have trouble differentiating polymorphism from just like inheritance. Could we just talk about that a little bit? Like
We can.
exactly what polymorphism is?
Yes, we can. Okay. So save this first here. Do I want to replace it? Yes, I do. Okay. So inheritance just means that you have two classes. Get rid of all. Let me start again. Okay, so if we do a real simple example, we can go back to our mammal example here. Okay, so we got class mammal. Okay. And let's say it just has. Okay, so it's going to have our underscore underscore init underscore underscore, and let's say it takes a self species. Okay, and it's going to set self dot underscore underscore species is equal to species. Okay, that's all it has. Let's say it has accessors and mutators. So we're going to have the get species, which takes just self, and it's going to return self dot underscore underscore species. That's our accessor, just one mutator. The set species, which takes the self species. I'm going to type species 13 different ways, my guess. And then it sets self dot underscore underscore species equal to species. Okay. So if that's all we have to begin with, okay, then we do a class. Let's do one here, the class dog. That should be a capital typically. Okay, so we're doing inheritance now. So we're going to say that dog is a mammal. Okay, so that's how we denote that. And then in our underscore underscore int, init, sorry, underscore underscore, okay, it has to take whatever we're going to add for dog. Let's do maybe breed. I don't know. So it's going to take a self. Okay. It has to take a species from the one above. Oh, no, it doesn't. Yeah, it normally does. It will. A species, and we're going to take a breed. Okay. When we create that. Okay. It's not going to take species because it's weird. Normally it would. It's not because we're going to set that. Okay. So if we have that, remember the first thing we have to do is call the mammals init, mammal dot underscore underscore init underscore underscore. Okay, it's going to take a self, and it's going to take for the species, we're going to send along dog. Okay. And then we're going to set the self dot underscore underscore breed equal to breed. Okay. And on this one, let's say we're just going to have our underscore underscore str underscore underscore, okay, which takes self, okay, and it's going to return species plus breed. That has to be those self underscore. Okay. Should work. Okay, so then our main, to clear what I'm doing so far, I could be messing up, one never knows. So now I should be able to test, say, m is equal to mammal, and we're going to give the species cat, let's say. And the d is equal to dog, give it the breed, something in the lab. Okay, see if that's working so far. Yeah, so far so good. Okay, so this isn't polymorphism. It just, the inheritance means that I can say print d dot get species. Okay, and it's a dog. Okay. So polymorphism has two parts. The first part means if I have a function that takes the superclass, it will take the subclass. Okay, so let's say I'm going to create a function called species. Okay, it's going to take an m, which we're assuming is a mammal. Okay, then I should be able to print out the m dot get species. Okay, then in main I should be able to say species m. Okay, let's see if that works. Yep, that worked. Okay, so on these typically we're going to say something like if is instance m mammal, then do this. Okay, which is going to be kind of a block for that. If I've got that correct, this should work because it's a mammal, and it does. Okay, so polymorphism says, well, what if I send it a dog instead? Okay, is it going to work? Okay, and it does. Okay, so even though this was meant to be a mammal, and I'm specifically testing to see if it's a mammal, the dog worked. Okay, so that's one version of polymorphism. Okay, does that make sense? We have the inheritance in that the dog is a mammal, and the dog has access to all the mammal stuff. Okay, we have polymorphism in that I created a function species that was meant to take a mammal, but it also took a dog. Okay, The other thing that this example did was a polymorphic function. So if I define whatever make sound, whatever it was called here, okay, and it's just going to print whatever it printed, seems like it's something like that, okay. Then polymorphism says also I can create another version of this program, of this method, okay, that's going to print out wolf. Okay, so now depending on, so down here I can say m dot make sound, okay, and it knows it's a mammal, so it's going to give me this version. Should line numbers again here. It's going to give me the version of make sound that's at 11, okay. Or if I say d dot make sound, because of polymorphism, it's going to know, well, I don't want the one at 11, I want the one at 24, okay. So we get the gur in the first case, the wolf in the other case. Okay. So again, polymorphism says that, so the polymorphism here is in line 37, where I can send any mammal or subclass of mammal. That's polymorphism. It's also polymorphism that I can define a function in line 11 and then redefine it in the subclass in line 24, and it'll pick the correct one. Picks the one that's most local to it. Okay. Make sense? Okay. Other questions? You can keep going, Amber, if you want. Questions are good.
If we have a little bit of time left, could we review indexing, like for, I don't know if we're gonna have any lists. Well, I guess we're gonna have probably lists with recursion, for like dictionaries and lists.
Oh, a dictionary and a list?
Or not in a list. I'm just talking about like indexing in general. I just wanted to review that, like,
Okay.
you know what I mean?
Well, I mean, you can't have a dictionary that includes a list, remember, so that's a possibility. So if we have list, range, I don't know, 20. We've got that there, okay? So the way the indexing works in general is it starts at 0 and goes up to 19 in this case, okay? But do you mean like the slices? Is that what you were confused about, maybe?
Not so much. I guess just, well, I don't really know what it would be called. I guess slices, pretty much just like calling part of a list, like using index like in your function. You know what I mean? Like, you know, you do like a, and then you would do like part of the list or just like one. I just want to review that for like dictionaries and stuff, because I know with dictionaries it's like you can call the key and it'll give you the value. Is that correct?
Yeah, and that's all you can do. So yeah, that
Okay.
I see what you're saying now. So let's take a look at that. So if we have D is equal to put something, I don't know. Let me do a phone book just because I have no creativity today. We've done this 1,000 times, but the idea should work. Okay. So we're going to associate a person with a phone number. Oh, I don't regret doing it in over here. We'll do another one. Associate it with. Okay, so we have that. So we can't do indexing like we normally do. Okay, that gives us a key error. Okay, that's the whole point of dictionaries. But I can do the PB of one of the keys, and that's going to return the value. Okay, I can do for key in PB and print the key. It's going to print the people that are there. If I do a for key in PB, if I want to print both, I can print the key, tab, and the PB key. That's going to print out that stuff. Okay. And then if I try again, something that doesn't exist, that's also going to give me the key error. Okay. But I could do something like Ted in PB, it's going to give me a false. If I say Bob in PB, it's going to give me a true. Okay. But remember again, I can do another dictionary. Let's redo this one. No, I'll do a different one. P is equal to, you could do like Bob with like a list. Okay. That's a colon. There's a whole section on that in the book. Okay. So now P of Bob returns that list. Okay, so I could say P of Bob dot append 7. Okay, so it works just like a list, but we can have lists there as well. Or we could have a tuple. We didn't add to the tuple, but yeah, that works. Okay. Did that help with what you were asking, Amber? I'm not sure 100% gave you what you needed.
Yeah, I pretty much just wanted kind of a review of how that works. That's
Okay.
yeah, that's pretty much exactly what I was looking for.
Okay, cool. A few more minutes. Anything else? Oh, something in chat. Let's see. Okay. Yeah, Tyson had to go to another class, which is fine. Anything else? You've made this a good video, Amber. I appreciate your questions. Your classmates will appreciate your questions. Anything else you want to know?
I think that's about everything.
Okay.
Unless you can think of something.
No, we got 3 questions. One's going to be on either dictionary or set. One's going to be on inheritance, maybe polymorphism. That could be in there. So that'll be
Yeah.
at least 2 classes. And there's one that's going to be on recursion.
Okay.
That's it. Okay.
Thanks,
I will
Dr. Frazier.
I will post this video if you guys want to take a look at it later.
Awesome.
Okay. If you have the questions, just text me. We'll figure it out.
All righty. See
Okay.
you tomorrow.
See you guys tomorrow.